Hello students, now we will discuss about analog to digital converter. On completion of this topic, students will be able to understand the basics of ADC. Analog to digital converter. An ADC inputs an analog electrical signal such as voltage or current and outputs a binary number. In block diagram form, it can be represented as such. Analog to digital converter. Connecting digital circuitry to sensor devices is simple if the sensor devices are inherently digital themselves. Switches, relays and encoders are easily interfaced with gate circuits due to the on-off nature of their signals. However, when analog devices are involved, interfacing becomes much more complex. What is needed is a way to electronically translate analog signals into digital quantities and vice versa. An analog to digital converter or ADC performs the former task while a digital to analog converter performs later. ADC IC ADC 0808 or 0809 is a converter that has 8 analog inputs and 8 digital inputs, which allows us to monitor up to 8 different transducers using only one chip. This eliminates the need for external zero and full scale adjustment. ADC 0808 is a monolithic CMOS device, offers high speed, high accuracy, minimal temperature dependence, excellent long-term accuracy and repeatedly and consumes minimal power. These features makes this device ideally suited to applications from process and machine control to consumer and automotive applications. This is the ADC pin diagram. Pin representation should be 1 to 5 and 27th and 28th pin will be an analog channel 1 to 5. These 7 pins are the input pins for analog voltage sensors. Pin number 6 will be a start pin. This is the input pin which is made high to start conversion. Pin number 7 is an EOC, that is end of conversion. This is an output pin which goes high once the conversion is over. Pin number 8, 14, 15, 18, 19, 20 and 21 is the output digital pins which gives the result of the ADC conversion. Pin number 9 is output EN, must be made high to get output on output pins. Pin number 10, clock, must be given to clock signals 0 to 5 voltage, 20 MHz approximately. VCC powers the IC typically with 5 voltage. V reference voltage pin, typically plus 5 voltage is used normally. Ground, connect to ground of the circuit. V reference is connected to ground normally. Address latch enable, that is ALE. This pin should be temporarily made high to select ADC channel. Add A, that is 23, 24, 25 pin numbers. Add A, add B, add C. These 3 pins are used to select the channel. ADC 0808 features easy to interface with all microcontrollers or works standalone. 8-channel 8-bit ADC module can measure up to 8 analog values seamlessly. On-chip clock not available. External oscillator is needed. Digital output varies from 0 to 2 to 55. Operating power is 15 milliwatt. Conversion time is 100 US. When V reference is equal to 5 volt, for every 19.53 millivolt of analog value, there will be rise of 1 bit on digital side. Available in 28 pin PDIP and SOIC packages. The ADC 0808 IC is a commonly used ADC module for projects where an external ADC is required. It is the 28 pin 8 channel 8 bit ADC module, meaning it can measure up to 8 ADC value from 0 voltage to 5 voltage, and the precision when the voltage reference is plus 5 voltage is 19.53 millivolt. That is, for every increase of 19.53 millivolt on input side, there will be an increase of 1 bit at the output side. This IC is very ideal to use with microprocessors like Raspberry Pi, BeagleBone, etc., or even to use an standalone ADC module. Every ADC module requires a clock to function. This IC requires an external clock pulse to work. Thank you, students.